Hello students, it's me again Mr. Ramsey and welcome to the lesson 3 of our science class. So the topic that we'll have today is about the scalar quantity and the vector quantity. So now we're going to review about the topic that we'll have last week, which is about the position of an object. So we have this word grid. So what is grid? So a grid is a series of lines perpendicular to each other. So when you say perpendicular, it overlaps each other in 90 degrees. Reference point. So what is a reference point? So a reference point is used to define the position of an object. So it is where the object is. It could be natural objects such as around us, such as the river, tree, or it can be anything man-made such as a road, bridge, and a building. So it is not moving. When you say reference point, it is a thing or a structure that is not moving. So you can see here, this one is the reference point where you can see if the boat is moving. Okay, the next word is dynamic objects. So what are dynamic objects? So dynamic objects, these are the moving objects wherein the movements are from one place to another. So as you can see here, the car is moving from one place to another place. Next is the static objects. So what are static objects? So these are objects that are stationary or just stay in place. So the table, you can see here the table is not moving. So this one is what you call a static object. Okay, so before we go to our topic, we will see first the vocabularies that we are going to use in this topic. Number one is quantities. Let's spell the word quantities. 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 Number two, scalar quantity. Let's spell the word scalar quantity. SCALAR. Scalar. Quantity. 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 Scalar quantity. Next word is vector quantity. Let's spell the word vector quantity. VECTOR. Vector. Quantity. 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 So vector quantity. Next word, size. Spell the word size. 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 Next word will be your magnitude. So magnitude is spelled as MAGNITUDE. Magnitude. Next word is direction. Spell the word direction. 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 Okay, so for today's topic, we are going to learn what is a scalar quantity and a vector quantity. So we will differentiate these two. What are the differences between the two? So what is a scalar quantity? A scalar quantity is a quantity that is telling us only the size or the magnitude. So size and magnitude are the same. What is a scalar quantity? Scalar quantity is a quantity that has magnitude only and has no direction in space. So examples of this are length, area, volume, time, and mass. These following quantities are what you call your scalar quantities because it only has magnitude or size, but it has no direction. Okay, the third definition of scalar quantity is a scalar quantity has magnitude or what you call your amount, includes the number or unit only, but it has no direction. When you say direction, it has like no north, east, south, west. Okay, so here you can see some examples of scalar quantities. Distance, 5 meters. So you can see here 5 meters only. Next is speed. Speed is 20 meters per second. It has no direction only the size or the magnitude, which is 20 meters per second. Next is mass, 3 kilograms, quantity only or the size, time, 4 seconds, volume, 30 ml. So these are some examples of quantities which are only having numbers or size, but it has no direction. Okay, let's go to what is a vector quantity. So vector quantity, it is a displacement whose quantity or amount specifies both size and direction. Here it is both size and direction. Another definition of vector quantity, a vector quantity is a quantity that has both magnitude, direction in space. Again, these have magnitude and direction in space. So examples of vector quantities: displacement, velocity, acceleration, and force. Again, some examples of vector quantities: displacement, velocity, acceleration, and force. So these following examples have magnitude and also have direction. So what are some examples of a vector quantity? So some examples of your vector quantities are displacement. So example, 10 meters north. 10 meters here is the size or what you call your magnitude, and north here is what you call your direction. So it is a vector quantity because of that vector quantity, it has size or magnitude and direction. So 10 meters here is the size and north here is the direction. Another example is your velocity. Velocity is 8 meters per second west. So 8 meters per second here is the size or the magnitude, and west here is the direction. Another example is your acceleration. So the unit of acceleration is meter per second squared. So that is 9.8 meters per second squared east. So 9.8 meters per second squared here is the size or magnitude, and east here is the direction. So acceleration is a vector quantity. Force. So force, 20 newtons south. So 20 newtons here, it is the quantity or size or what you call your magnitude, and south here is the direction. So the examples here have size and direction. So these are what you call your vector quantities. Again, so vector quantities are quantities that have size and direction. Okay, I have here some examples of comparisons of scalar and vector quantities. For example, so for scalar quantity, distance, for distance it's only 40 meter squared. So 40 meters squared is only a scalar quantity because 40 meters is only a size or magnitude. On the other hand, vector quantity, which a quantity with size and direction, the answer, some example is what you call your displacement. So displacement here, 40 meters is direction. So 40 meters here is what you call your size or your magnitude, and east is the direction. So these have size and direction. This is displacement is an example of a vector quantity. Next will be your speed. So speed, 30 meters per second. So 30 meters per second is an example of a scalar quantity. It is because 30 meters per second is only a size or a magnitude. Whereas vector quantity, the example is velocity. So velocity here, The example of velocity here is 30 meters per second squared north direction. So 30 meters per second squared is the magnitude or the size, and north direction, this is the direction. So it has size and direction. That's why it's an example of a vector quantity. Next, the example of scalar quantity is time. So time here, 15 seconds. So 15 seconds is a scalar quantity because it's only a size or a magnitude. Some examples of vector quantity is force. So a force, 100 newtons upward. So when you say upward, it may be north. So 100 newtons north or 100 newtons upward. So 100 newtons here is the size or the magnitude, and upward here is the direction. Next example for scalar is energy. So energy is 2000 joules. So 2000 joules is only a quantity, or it is a size or magnitude. Okay, so that's why it is a scalar quantity. How about acceleration? So acceleration here is a vector quantity. It's because it has size, which is 98 meters per second, and downward direction. So there's a direction which is downward or going to south. So that it means that acceleration is a vector quantity because it has size and direction. So remember, so for comparing scalar and vector, so scalar, again, it has magnitude only. So magnitude refers to size only, but has no direction. But vector, it has magnitude or size and a direction. Okay, so here are some examples of your scalar quantities: mass, length, distance, speed, power, energy, work. So these are your scalar quantities. Vector, so what are some examples of your vector quantities? Displacement, velocity, acceleration, force, weight, friction, momentum. So these are your vector quantities. So another one is here. Another example is scalar quantities are your length, your area, your volume, your speed, mass, density, pressure, temperature, energy, entropy, work, and power are all examples of your scalar quantities. For your vector quantities, these are your displacement, velocity, acceleration, momentum, force, lift, drag, thrust, and weight. So these are some examples of your vector quantities. So you can differentiate this with each other because scalar quantities, again, has only magnitude or size, but vector quantities have magnitude and or size and direction. Please study this part because it will be part of your quiz later. Okay, so for additional information about this topic, please watch the video attached and answer the quiz in your Google Classroom. So thank you everyone. See you soon.